The camera light cuts through water that has been sitting in absolute darkness for longer than humans have existed, and something pale drifts into the frame. It shouldn't be there. Not at that depth. Not under that pressure. Not in a place scientists had spent over a century describing as empty. And yet there it is, moving without struggle, without urgency, as if the deadliest environment on Earth were nothing more than an ordinary afternoon. This is the story of how a single piece of footage, filmed at the bottom of the Mariana Trench, forced an entire branch of science to admit it had been wrong about the deep ocean for generations. To understand why this moment mattered so much, you have to go back to what scientists actually believed about the deep sea before cameras could survive down there. For most of the 19th and 20th centuries, the working theory was simple and, on paper, logical. Sunlight fades out around 3,000 feet. Below that, there are no plants, no photosynthesis, and almost no food falling from above except the slow drift of dead organic material scientists call marine snow. Add crushing pressure and near-freezing temperatures, and the conclusion seemed obvious. Nothing complex could survive down there. The deepest layer of the ocean, known as the Hadal zone, was even named after Hades, the Greek god of the underworld. Scientists were not being poetic. They genuinely believed they were naming a graveyard. In 1960, that belief was tested directly. A vessel called the Bathyscaphe Trieste carried two men, Jacques Picard and U.S. Navy Lieutenant Don Walsh, down to Challenger Deep, the lowest point in the Mariana Trench and the deepest known spot on the entire planet. They reported seeing what looked like a flatfish resting on the bottom. It should have been one of the most important zoological observations of the century. Instead, the claim was met with skepticism for decades, partly because the visibility was poor and the technology of the era simply couldn't capture convincing proof. Many researchers quietly dismissed it. The idea that life could not exist at that depth was too deeply embedded to be overturned by a blurry glimpse through a small viewport. The turning point came gradually, not all at once. In 1977, researchers discovered hydrothermal vents on the deep ocean floor, and around them found entire ecosystems thriving without sunlight, powered instead by chemosynthesis, a process by which bacteria convert chemical energy from the Earth's crust into food. It was a genuine shock to biology, proof that life didn't need the sun to build a food chain. But even that discovery happened at depths far shallower than the true Hadal zone. The very deepest trenches, 7 miles down, remained essentially unphotographed and unstudied. The technology to survive that kind of pressure long enough to observe anything simply didn't exist yet. That changed in 2019, when Victor Vescovo, a Texas-based private equity investor and former naval officer, launched an expedition called the Five Deeps, with the goal of piloting a submersible to the deepest point of all 5 of the world's oceans. His vessel, the DSV Limiting Factor, was built specifically to withstand the pressure at Challenger Deep, roughly 8 tons per square inch, enough force that a single structural failure would kill a person almost instantly. Vescovo made the descent alone, a nearly 4-hour drop through total darkness, followed by hours on the seafloor and another 4-hour ascent, all inside a sealed titanium sphere with no possibility of rescue if anything went wrong. But the person who mattered most to this discovery wasn't in the submersible. He was on the support ship above, watching monitors fed by a high-definition camera system mounted to the sub's exterior. His name is Alan Jamieson, a Hadal Zone biologist who spent his career at Newcastle University before later continuing his research at the University of Western Australia. Jamieson had built much of his career studying the very depths most of the scientific community treated as a footnote, using baited landers and remote cameras to slowly chip away at the old assumption that the trenches were barren. When the footage from the limiting factor came up to the surface, he wasn't watching for spectacle. He was checking it against years of careful expectation, the kind of expectation built from evidence, not guesswork. What the footage showed did not match those expectations at all. The first thing to appear on camera, once bait was placed in the water, was a swarm of amphipods, small shrimp-like crustaceans that are common throughout the ocean but are rarely seen in such numbers. In shallower water, amphipods might grow to less than an inch. In the trench, they were reaching 6 to 8 inches in length, an oddity biologists sometimes describe as deep-sea gigantism, and there were so many of them that they didn't look like individual creatures anymore. They looked like a moving haze, a living cloud converging on the food source with the kind of aggressive, competitive energy you'd expect from animals with abundant metabolic reserves, not creatures barely scraping by in a food desert. Then came the sea cucumbers, soft-bodied and unhurried, grazing across the sediment exactly the way their shallow water relatives do. Nothing about their movement suggested distress or endurance. They looked, for lack of a better word, at home. And then the camera caught the animal that would end up defining this entire discovery. A snailfish, pale, almost translucent, gliding through the beam of light with total ease. Snailfish are a family of soft-bodied fish that, unlike most deep-sea creatures, lack the heavy skeletal armor you might expect from something built to withstand extreme pressure. Their bodies are largely water and gelatinous tissue, and that turns out to be exactly why they can survive down there. Because their tissues contain almost no compressible airspace, the pressure pushing in on them is matched almost perfectly by the pressure inside them. There's no vacuum for the trench to collapse. In 2014, Jamieson's team filmed a snailfish at a depth of around 8,145 meters in the Mariana Trench, and in the years that followed, further expeditions using baited cameras recorded a related species, later described in 2017 in the journal Zootaxa as Pseudoliparus swirii, at depths exceeding 8,000 meters, making it among the deepest living fish ever documented on camera. In 2022 and 2023, follow-up dives led by Jamieson's team recorded snailfish even deeper still, in the Izuogasawara Trench near Japan, pushing the known depth limit for fish life past 8,300 meters. Each of these records chipped further away at a boundary scientists had once assumed was fixed. What made the footage unsettling wasn't just that these animals existed. It was how they behaved. The prevailing assumption, even among specialists who accepted that some life might survive down there, was that anything living at those depths would be sluggish, minimal, conserving every unit of energy in a cold, food-poor environment. That assumption made biological sense. Less available food and near-freezing temperatures should force organisms to slow their metabolism to a crawl. Instead, the amphipods moved fast, aggressively, competitively. The fish swam with the same fluid, unbothered motion you'd see in shallow coastal water. Nothing on screen looked like survival. It looked like an ordinary ecosystem going about ordinary business, just 7 miles beneath the surface, under conditions that would kill a human being in less time than it takes to finish a sentence. This forced Jamieson and other researchers to reconsider not just how much life exists in the Hadal zone, but how organized it is. What the cameras captured wasn't a lone hardy species clinging to survival. It was a layered food web, scavengers, filter feeders, predators, each occupying a distinct role, the kind of ecological structure that doesn't appear overnight. Structures like that take long stretches of evolutionary time to form, which raises an uncomfortable question about how long these communities have quietly existed beneath us, entirely unnoticed, while the scientific consensus insisted nothing was there at all. There's still a significant piece of the puzzle scientists haven't fully explained: what is actually feeding all of this? The traditional answer is marine snow, organic material drifting down from the surface over the course of days or weeks. But when researchers have tried to calculate how much marine snow could realistically reach depths of 6 or 7 miles, the totals don't come close to supporting the density of life the cameras recorded. Some of the answer may lie in localized chemical processes on the seafloor, though hydrothermal vents haven't been found throughout the entire trench system. Some researchers, including Jamieson, have proposed that trenches may act as natural collection points, funneling organic material down their steep walls more efficiently than flatter regions of ocean floor, effectively concentrating what little food exists into pockets far richer than anyone predicted. It's a reasonable hypothesis, but it remains an active area of research rather than a settled answer, and that gap between what's been observed and what can currently be explained is, in itself, one of the more striking parts of this story. The discovery also carried a darker footnote, one that had nothing to do with biology and everything to do with human impact. When Vescovo's submersible reached the floor of Challenger Deep in 2019, the cameras recorded a plastic bag and what appeared to be candy wrapper debris resting in the sediment, 7 miles down, in what had been considered the most remote, untouched location on the planet. It wasn't the first sign of this kind of contamination. In a 2017 study published in Nature Ecology and Evolution, Jamieson and his colleagues examined amphipods collected from 6 of the world's deepest ocean trenches and found that the vast majority of the animals tested carried measurable levels of persistent organic pollutants, including compounds historically used in industrial insulation and banned decades ago in most countries. In some individuals, the concentrations were comparable to those found in heavily industrialized and polluted coastal waters, despite the animals living in one of the most physically isolated environments on Earth. The implication was difficult to sit with. Life at the bottom of the world had barely been confirmed to exist in any detail before evidence emerged that human waste had already reached it, quietly, long before any camera did. What makes all of this significant isn't a single dramatic image, even though the snailfish is the one that tends to stick in people's minds. It's the pattern underneath it. Every time researchers have drawn a firm boundary around where life can or cannot exist, that boundary has eventually moved. The deep ocean was supposed to be silent and empty. Then hydrothermal vent ecosystems were found thriving without sunlight. The Hadal zone specifically was supposed to be the final, uncontestable frontier of nothingness, the one place pressure alone should have made survival impossible. Then cameras built to withstand that pressure went down and recorded a functioning ecosystem instead. None of this means there's some undiscovered monster waiting in the unlit portions of the frame, and it's worth being honest about that rather than exaggerating it for effect. The footage from these expeditions covers only a small illuminated radius in a trench system that stretches for over 1,500 miles along the seafloor. Most of it has never been filmed at all. What the discovery does mean is that the old justification for dismissing the deep ocean, the assumption that nothing worth studying could survive there, no longer holds up. Every organism that has turned up on these dives, from oversized amphipods to a translucent fish thriving under pressure that would instantly destroy a human body, represents a small, specific correction to a scientific consensus that had gone unchallenged for over a century. Alan Jamieson has spent years arguing that the Hadal zone deserves the same scientific attention as coral reefs or rainforests, not as some curiosity at the edge of biology, but as a functioning, ancient, and largely unexplored ecosystem in its own right. For a long time, that argument was met with limited institutional interest, in part because the trenches are difficult and expensive to study, and in part because the assumption of emptiness discouraged the kind of sustained research that shallower ecosystems received without question. The footage from the 2019 expedition, and the confirmed depth records that followed it in subsequent years, gave that argument a kind of evidence that's hard to dismiss. You can debate a theory. It's much harder to debate a fish, alive and moving, filmed at a depth previously assumed to be biologically impossible. There's something quietly humbling in all of this, beyond the science itself. Human beings have mapped the surface of Mars in more detail than we've mapped our own ocean floor. We assumed, with real scientific confidence, that we understood the limits of where life could exist on our own planet, and we were wrong, not in some minor technical sense, but fundamentally wrong about an entire layer of the Earth. The deepest, coldest, most crushing environment we know of turned out to be busy, organized, and in its own way, thriving, while at the same time already carrying traces of the world above it, in the form of plastic and industrial chemicals that had drifted down long before any camera arrived to bear witness. The story of that pale, fragile-looking snailfish drifting calmly through the dark isn't really a story about a strange creature. It's a story about how much confidence scientists once placed in an assumption that turned out to be incomplete, and how a single stretch of footage, 4 hours down and 4 hours back, was enough to make an entire field stop and recheck everything it thought it knew. Somewhere in that vast, unlit trench, past the small circle of every camera light that's ever reached the bottom, there is almost certainly more waiting to be found. Not because the ocean hides monsters, but because it hides evidence, patiently, in a place we only recently learned to look.